Spent 3 hours debugging and it was a single missing semicolon. How many times you heard this one before? Very funny joke, I know. But riddle me this. If the compiler knows that the semicolon should go here, can it just insert it itself? Why do I have to do that? Spoiler alert, it actually can. So here I have a tiny C compiler, which is a very simple implementation of the C compiler. And what I like about this implementation is that it's so simple, it is very easy to find where exactly the compiler expects this semicolon. So the way you usually explore any code base, you try to grab for error messages. So here we have an error message, and it looks like the unique part that is not really changing very frequently is this one: expected space parent got. So let's literally grab this combination of characters. And what we find in here, so there's some unit tests in here, and here is the only place where this happens. Okay, it's inside of a function skip, and it expects some sort of a character, so I suppose skip a particular token. It compares that expected token with toc, which is neither the function parameter nor a local variable, which means it's probably a global variable of some sort, and it is in fact a global variable. So I suppose what the Alexa does of this compiler is that it stores its own state in global variables, which is fine for very simple applications. And if the current token is not equal to the expected one, it just throws an error, and if it is, it calls next, which I suppose advances the tokenization, right? So we're going to presume that it in fact advances tokenization. So what that means we need to find all of the places where a skip function is called with a parameter, with a value, I would even say, of a semicolon. And there's quite a few of such places. Okay, let's take a look at the first place. So this is a function, and it's a pretty long function. Let's actually find the beginning of the function. So let's actually search for a curly brace that starts at the beginning of the line, and that is surely the start of the function. So this is something related to structures. So we're not working with the structures, we're working with statements. So let's take a look at the next one. Okay, this is still structure. What is that one? This is expression. We're not working with expression. Okay, this one is interesting. This is a block. Usually in programming languages, block is a sequence of statements. So let's see what we have in here. We're taking the next token, and look at that. This is interesting. So the block can start with token if, token while, okay, so a curly brace, a return, and so on and so forth. So logically, there should be somewhere a case in here which is just an expression which ends with a semicolon, which is exactly our case. This is just an expression that is supposed to end with a semicolon. And in here, they literally have an expression case. Okay, so if t, which is suppose some fetched token, not equal to semicolon, we're, I guess, untokenizing it and then trying to parse something related to expressions, right? And then we're skipping the semicolon, right? So, and the semicolon is expected to be there, otherwise it will throw an error. So if toc is a current token, we can do a very interesting thing. Let's say if token is equal to semicolon, only then try to skip it. And if it's not equal to semicolon, don't even try to skip it. That way, we're rendering that semicolon at the end of the expression optional. So let's try to compile the entire thing. So we're recompiling the compiler. And now let's try to recompile our application, our hello world, without a semicolon. And it compiles, and let's try to run the program, and it works. We can even add more print statements, for example, foobar, and it will still work. And we can even put them on the same line, it will still work. You don't need a semicolon. This is the greatest semicolon conspiracy, but not really. The way I discovered this idea is I was working on my B compiler, and B, for those who doesn't know, is a predecessor to C. Ken Thompson and Dennis Ritchie first implemented a programming language called B, and then they improved it and called it C. So what I just did a little bit of a historical experiment and was implementing the B compiler. And as I was implementing the syntax of the B compiler, I noticed a very interesting thing. So the syntax has a notion of a statement, and statement is anything that starts with if, while, switch, go to, return, and R value that ends with a semicolon. For those who doesn't know, R value is any expression that you can put on the right side of the variable assignment. That's why it is called R value. Anything that you can put on the left side of the variable assignment is called L value. value. So any R value can act as a statement if you put a semicolon at the end of it. And since C inherits B syntax, it's basically the same for C. But if you take a look at the definition of R value, you will notice that there's no a single semicolon in there. In fact, if you try to implement the parser for R value, you will realize that it always terminates. Parser always knows when the R value ends. It doesn't need a semicolon to know the end of the expression. And it feels like the only reason you need a semicolon is for humans, right? So because maybe it is not particularly readable that you can take this entire expression, put it in here, and that will still work. And the question is, how many expressions do you even have in here? You have to put a mental effort into parsing each individual expression in here, right? So, but if you are forced to put semicolons between them, it is kind of easier. So, and honestly, the fact that this decision was probably made specifically for humans is confirmed by a more modern languages like JavaScript and Go implementing automatic semicolon insertion, because it is very easy to kind of forget a semicolon in these specific cases, so you kind of want to relax that rule a little bit. Personally, I like this idea that you don't require a semicolon for lines that contain only a single statements, but if you put two statements on the same line, only then you require a semicolon. As far as I can understand, Go works like that. So what do you think? Are semicolons between expressions really needed, or is it just a waste of hard drive space?